connection. Hello everyone. Welcome to the next episode, number 6 of the Working Software series. In this episode, we're going to talk about LINQ, the functional stream processing library, sequence processing library from .NET, which has been around for, I don't know, maybe 10 years already, but which still requires attention and explanations. And you will see what I mean by that during this session. I always feel embarrassed when I have to talk about the LINQ, because I feel or I expect that everyone is a master of using LINQ. But it appears that it's not so, and so I chose to hold this session to help clarify some thoughts you might have about LINQ. Where is the LINQ's place in modern programming? What is the LINQ's core purpose? Apart from being fairly easy to use and apart from sometimes creating expressions that are hard to read, LINQ has a hidden power in modeling and especially in prototyping your classes. And that is what I'm going to show you in this presentation. You will see how powerful models can be constructed with no effort using LINQ. So, let's start. This is the application which I will use to demonstrate some LINQ expressions. It is an example which I'm using very often in trainings and workshops I hold to teams. It is a very interesting example and a very funny one, I think. By the way, it is a Blazor WebAssembly application which does not affect this presentation too much. It is a tic-tac-toe game, an excellent example on which you can show so many principles of programming. As I said, it is a WebAssembly application. It has a few components in the UI, and what is important to this demo is what lays here in the shared project. That is where the main models are located. The principal model which we will develop today is board. That is the board which is displayed in the UI. There's also a helper class named cell, which only gathers row and column index, and there is also a line model which is modeling a winning line, for example. It starts from one cell and ends on the other cell. Its constructor is private because there are 4 distinct factory functions for row, column, diagonal, and anti-diagonal. So that is the model. In the UI, the principal component is this one called play. I have already drawn a fixed position on the board with 4 moves made by the home player and 3 moves made by the away player. And there is also a winning line here, which is an anti-diagonal diagonal. So again, if I start the application, you will see that position drawn on the screen and the home player winning there. So the task in this demo is to develop this game so that the player can play on the screen. I will pretend that I'm both home and away player. We're still not there to developing playing over the internet, for example, multiplayer operation, but that doesn't affect this demo. The point is, in this demo, to allow a user to click these cells to make moves in alternating order and to display the scoring line or lines, because there could be two lines crossing in some cases, so that we can see the game unfolding and ending regularly. Therefore, I will delete all this and start all over again. You will see in this demo that more or less everything in this game can be implemented using LINQ. If you have ever coded a tic-tac-toe game before, because that is a well-known example for learning programming, you may have been thinking about how to represent state. Let's go to the board. How do we represent state here? And then you say, maybe a list of moves, maybe, I don't know, maybe a matrix, maybe an array of cells, maybe even a bitmap, which is the fastest method. But I will advise you not to think about state before you figure what is the API of this model. So in modeling, I will always advise you to start from the interface, from public interface. What is this class going to do for us, for the callers? And the caller is this page here, this component, which needs to display symbols that were put by the players and display winning lines. Also, it will be responsible to allow playing, making moves. So we start from the consuming end and we go in top-down style, hoping that that will lead us to writing a better board model, the more useful board model. So we need to display those symbols. Those are represented by home cell, here it is, and the away cell components. This one is drawing an ellipse, which looks like O, and this one is drawing a two crossed lines to look like X. So we need to place those components here. How? By asking the board to give us all cells, for example, played by the home player. In board.what. So we could say home cells, cells occupied by the home player. And once we obtained a home cell, we could say home cell and the location is home, this one. I cannot imagine anything simpler than this in the UI, on the consuming end. So when it comes to the board, I think that it will be the best for the consumer to expose an enumerable of cell, home cells, and that there would be a getter. And as I haven't developed this board yet and there's no logic in it, I might say that there were no moves at all so far. So as of this moment, home player didn't make any move. When you see things like this property getter, LINQ is the first thing on mind when it comes to using or generating, producing this property. Why is it so? Because I have opted to expose an enumerable of cells. And why did I do that? I did that because on the consuming end, we have a wonderful construct named for each, which consumes enumerable. So if the object could produce a sequence of cell objects, then the consumer could easily consume it. There's nothing to do here, just walk through those and generate one component for each of the cells found in the sequence. That is the modeling process which I'm following when I design my own projects. And you will see how that top-down or from the outside to inside development model will lead you in the way of putting LINQ into the place where it naturally fits. I will also expose away players' cells and also enumerable empty, so that I can repeat the same process for the away player for each cell away in this board away cells. This time I will put away cell component, location is away. All right. What else? We also need those winning lines because the game might be over in a victory. So let me ask for a line. But there could be 0, 1, or 2 lines on any board, in any board position. And I will ask for winning lines. Again, another sequence. And here it is. This is the user interface. On the board end, no lines, it will be another empty sequence of lines, because at the beginning of the game there's nothing to show. This modeling method is also, what am I doing? Well, winning line S, multiple lines. Okay. This modeling method is based on making small steps, small advancements, so that in every little step you're adding one tiny item to the design, and the entire design is correct through the entire process. So you can always run the application and it will work. It will do whatever was coded so far, which is pretty much nothing, but at least nothing is breaking. We have an empty board to start playing on. There is still no place for LINQ here nor for anything else, because I'm working with the empty board, a model of an empty board. And now we start thinking, how do we make a move? For example, okay, let me show you one. Sunny Patel, will this code base be shared? Yes. I will show you the link. There is, on my GitHub profile, you will find the working software repository with all the code displayed so far. I will put the final code as well, so you can open the initial code already, and the final code will be there by the end of the day. So, making moves. There is a model named clickable cell, which I haven't been using so far, and it has an action called play. So technically, on an empty board, I could place a couple of clickable cells. Location could be here, and play, I will use an empty action, nothing, just to avoid exceptions. But you will see what happens when there are clickable cells on the board. You will effectively be able to click them. I have put a couple of them so that you see what they look like. Here you will see faint blue color. These can be clicked, and whenever I do click, that empty action will execute. And these are not clickable. So the point is that when the game begins, everything should be clickable on the board, and all occupied cells should not be clickable anymore. And once the game is over, nothing should be clickable after that. If somebody scored a line, there should be no empty cells should be displayed in blue and allow clicking. How do we do that? Again, by another sequence. Cell empty in. But how do I name this property? Could I say empty cells? I think no, because a cell could be empty but not allowed for playing, for example, because the game is over. So I might call them playable cells and add a clickable cell for that. Location is empty, and play will again be this empty action, because I still don't know what it means to play. On the board end, let's add that additional playable cells. Okay. This is not correct. All cells should be playable initially, so we are starting with some real modeling. There's no running away anymore. By the way, play has only a restart method, but we could add a play cell at. This method, no, it cannot be named play because the class is already that with that name. Make move, for example. So I could say this make move at this location. So the UI is over, it's done. I'm not sure that I will have to change anything here in the future. And now we say what? We need to make a move. But before doing that, I want to solve the problem of having no playable cells. All cells must be playable. How do we create them? This is where using LINQ begins, because LINQ is an exceptional tool in modeling sequences. Whenever you have a sequence of objects, you will probably be able to model it using some LINQ expression, regardless of how ugly it is, how maybe slow it might be, anything. You can write an operational working model which will be just good to begin with. We shall think about how useful those models are, those expressions really are later. We cannot think about performance. We cannot think about memory consumption. Nothing right now, because we don't have a board that works. That is the point. So let's start. Range. Let's create how many? I have a static class with parameters which say what is the dimension of the board. I might also give a name, so it is a constant free right now. Let's add total number of cells as well. So I want 9 items. For each offset, this is the row-wise offset, I want to create a new cell with row calculated as this and column calculated as this. And those are all the cells in the matrix. What will happen when I run this? You see, all cells are faint blue. I can click them, nothing will happen, but we have 9 clickable cells right now. One step away from the beginning, and the first LINQ expression which generates a matrix, a row-wise matrix. By the way, I might go to the cell because I think that this knowledge belongs here. And say row-wise matrix and put it here as a factory function, static factory. So that on the consuming end, now board has become a consumer. We can say cell row-wise matrix, and that is all. This modeling style may remind you of something you have already seen, for example, in testing, in TDD precisely. When you write tests, then satisfy them in the simplest possible way. Make sure that tests are passing after that. And right at the moment when you think you're done, you figure out that you're not done, but you get back to the code which is satisfying the tests and refactor it. So what I did was to develop the simplest of all models which works. And then I refactored it so that this class board does not have to carry that burden of knowing how to construct a matrix of cells. That is somebody else's job to do. And again, we have a very simple code so that we can start thinking about what happens when a cell is really clicked. And I might say something like this: make move at this location. By the way, I don't like having a mutable board. I have a reflex to make all classes immutable by default and only turn them mutable if really needed. If there is something, and that will probably be a performance consideration, that forces me to mutate state. So I will expect make move to construct a new board. And how do we model that? Well, by not doing anything. I'm not going to make that move, because at the first attempt, I want to have a place for the feature. Nothing will happen except that this time, this is the place where nothing will happen. It used to not happen here. Now it is not happening one step further away in the board. And we have another method, make move on the board, which is useful and where we can think about what it means to make a move. It means to store it somewhere. And this is the moment when we get on to defining state. This is up to this moment, it's been 20 minutes of development already. I had no reason to think about state. And what kind of state will I choose? I will think of the simplest state which will allow me to implement these properties, because these properties are mandatory, everything else is optional. And I think that it's a good idea to have a collection of moves here, but since this board is immutable, I will add an immutable list. So I will have to install it. Where are you? Okay, immutable collections. I will add it to this project. I think that an immutable list is a good candidate to model state because it doesn't ask for too much. You can just have a list of moves, append every move to the end, and you will have all the moves there so that you can calculate everything here. So let's do that. Here. But since this class is supposed to be immutable, I will have to follow a usual protocol of creating immutable classes by having a public constructor which accepts mandatory parameters for the initial state of the object, which is nothing right now. In this class, board with no parameters is an empty board, and a private constructor which accepts the entire state of the next object in the chain of objects that are creating each other. So there will be moves, and this one will simply create an empty list of moves. So this is the usual protocol for immutable objects. Two constructors. The private one is used to construct the next object in a line. So this will be new board. This moves, add this cell. Add method on the immutable list is returning a new immutable list, and we are happy. Technically, I have just added a move to the board. Nothing will work correctly yet because home and away cells are not being displayed, but inside there will be those symbols. There will be those. So the first thing I want to correct is to remove those cells which were clicked from the list, from the sequence of clickable cells. Another task for LINQ. So if we had a matrix containing all 9 cells on the board, what will be the playable cells after some moves were made? There are some moves here. Well, except this moves. it's done. Because if you think of the playing board, you will say that playable cells are all the cells on the board except those that were occupied. And you can write LINQ expressions the very same way you speak of them. If I run the application now, I expect some of the cells to start disappearing or turning gray because I clicked. No, what's happening? What did I do? I'm making the move. I'm making the move. Calling refresh. Can somebody tell me where is the bug? I'm returning the new board. Okay, let's start debugging. If you can tell me where is the bug, please do so. Nine. Something is wrong here. What am I doing? Oh, yes, of course. A bug. It's very funny that I made it, and very good to see it here, because when you start using operators like this one, your classes will have to be adapted to the use, to the way LINQ is using them. So LINQ is a functional library. It is applying functional transforms. You would take one sequence of objects and add a transformation function. So to create another sequence of objects, or to reduce it to a single object, to aggregate it. Those operators are making some assumptions. For example, if you want to use except operator, this class must be a value object. It must be comparable for equality. And I forgot to do that. So the first thing, I will seal this class and I will override equals so equals if object is a cell and row is this row and column is this column, that will be enough. And get hash code will follow this row and this column are to use. So after this change, cell will behave as a value object, and it will be useful to the except. Here it works. To the except operator. Every cell I click will simply not be clickable anymore. I cannot click it. Nothing will happen if I do. So another feature is there for the use of another LINQ operator plus adapting a class, turning it into a value object. But how do we do these? By applying another LINQ expression. Like, starting from moves, we need to take all moves on odd positions, or, since indices are zero based, on even index positions. So there is that form of select which says cell and offset. We can remember that. So to ask for those with offset evenly divisible by 2. And returning only the cells. This is the LINQ expression which calculates home positions where home player played, from all the moves which are representing the history of moves. If I start the application now, you will see that it will work, at least when home player. Here, all home players' moves have been displayed. I might want to repeat that for the away player, but I have a better idea. I might take this expression and turn it into a method which receives parity. Here, so that this parity is parameterized. And again, I will simply use that. With parity 0 and with parity 1. Do you see how easy it is to model this class using LINQ? My intention was to create a prototype, a working prototype for the board, which can be used to play. Here, the game should be over. There are no lines yet, so that is the next feature I will develop. But so far, I got away with, I think, three LINQ expressions. This one, the one hiding behind this, and this one. 3 LINQ expressions are modeling the gameplay. Now we need to model scoring. And after that, the board will be almost over. There will only be a few brushes left to make, and everything will be done. How do we select winning lines? Well, since we cannot start from the moves, I think, because those are home and away players' moves mixed together. We need to start from this one and from this one. So one valuable technique when working with LINQ is to build new expressions out of those that you already have. So I will say this home winning lines, which I don't have yet, concat away winning lines. And that would be all once I had these two. So home winning lines will be one property getter and another, no, away winning lines. And then we think, how do we construct these? Those would be some LINQ expressions again, but those expressions would look almost the same. And I will introduce another helper method which will solve that for me. Here, again, observe how I'm building a larger chunk of functionality out of smaller ones. I have not started writing the entire expression here. I want to break it down into components, and those components I want to pull out what is common for them, so that in the end I only have one place to write a nasty piece of LINQ. How do I find lines? Do you know what a line is? That is a collection of free cells that compose a line. So if I knew a line, like a column with index 2, and I found free cells belonging to that line, that would be a win. On the other hand, one cell can belong to multiple lines, to 2 lines at least, plus 1 or both diagonals, so 2, 3, or 4 lines. So this is how I'm thinking. For each move, I could ask that move for the lines where it belongs. And since move is the cell, I could create a property getter which returns lines for this cell. I hope this is not confusing you, because if you look from the consuming end, by using select many operator, I will be able to turn the cells played by one player into all the lines that were occupied, where each appearance of a line means that one cell is occupied on that line. And now, if you think about that in that way, you will see that I have effectively simplified the problem a lot. Because after that, I want to group those lines by the line itself, so that I can isolate those lines that appear 3 times, which means that player played 3 times on that line. And when that happens, I have the winning line, 0, 1, or 2. And I can return that line. This is the nasty expression which finds all winning lines for one player. And it depends on 2 elements. One of those is this property getter on the cell, which should return all the lines to which this cell belongs. So I will use line row, this row, and this column. So it definitely belongs to a row and to a column. And it might belong to a diagonal. So if row and column are equal, then it also belongs to diagonal. And if sum of row and column plus 1 equals dimension, then it is the anti-diagonal. This property getter is done. Every cell will return 2, 3, or 4 line objects where that cell belongs. So, one more element is missing, the same one that was missing in the cell. Since I am grouping by the line must be the value object, since it is used as the key, as the grouping key. So let's seal it. Implement equals so line from equals this from, and line 2 equals this too. Okay, and I need get hash code, which depends on from and to here. Those were the two elements that were missing for this expression to be correct. And let's see. Here, the line is drawn. Let's see if I could make, oh, restart doesn't work. If I could make two lines to cross, I will clear the board by creating the new one, and that is the restart. So how do I make two? That would be both players must play together for one to make two lines, and here they are. That works. So my expression is returning 0, 1, or 2 lines in every position. Okay, this works, and it's fairly simple. You know that LINQ expressions can be nasty, can be very ugly to read. These are not ugly. This is manageable. By the way, you can write your own LINQ operators where you need them. I will add a class for my own LINQ operators, just to show you, like this one. That is this, where are you? This expression with parity. So I will start with sequence. I will use an object, and here you can see a perfectly reusable operator which returns elements with specified parity. So I don't need select cells. I could start from moves with parity and moves with parity. And so I have removed the ugliest, I think, LINQ operator from my code. This is the entire board. By the way, there was a bug here because when the game was over, the remaining cells were still clickable. I think that this is not correct. This expression here, no, is actually representing empty cells, and we already concluded that empty cells are not what we are after. We want cells that can be clicked. And here is the idea. If there is any line, another LINQ operator, if there is any line, then there are no clickable cells or playable cells in terms of the board. Otherwise, here, it's either the empty sequence or all empty cells on the board. And with this, I think that I have finished developing this board. The game can be played and restarted, and it will end when somebody scores. Here. No, I cannot score here. All right, here, fork attack. And you see, these two became gray because the game is over. So, we have the board implemented from scratch, and everything is working fine, and everything was implemented using LINQ. Everything. If it were only for playing on the screen, this development will be over. There's nothing to do here anymore. If you thought that I will use some matrix, some bit mask or anything as state and then optimize these selections over that state representation, you might be disappointed to see me using the slowest of all solutions, an immutable list plus LINQ expressions on every single call. I believe there are not many implementations slower than this one. But again, if it were only to play on the screen, what's the point of being any faster than this? Everything is happening instantaneously. So from the point of view of modeling and prototyping, which were the title of this talk, that is modeling and prototyping. It simply works. Everything is done the way it was requested. In the future, somebody might say, oh, this is taking too much power from, I don't know, mobile phones, from mobile devices, so we might optimize this a bit for the sake of battery longevity. But that's a totally different story. As of now, all the requests are implemented. However, that is not all I wanted to implement. So the customers come and say, we want in every board position, you may have noticed this 0 continuations, we want to count games that follow from every board position. If you search the internet right now, you will find that there are some 255,168 games that can follow from the empty board. I want that number to be displayed here. And that is where using LINQ in this way might become a problem. From performance point of view, because I was very extravagant with resources here, I never paid attention to any resources so far. So where does it stand? Here it is. I want to start from the board and count continuations to have an integer to display here. and format it a bit. So I want to have a method like this one, and that will show that this implementation is really not good. I will make an incorrect number here so that we can see when it starts working correctly. Again, I'm adding a placeholder for the new feature. Here, it's displayed correctly, only the value is not correct. How do we implement this? What do you think? Sunny Patel, will I do more videos on good practices? That might happen in the future. Okay, how do I count continuations? I'm stubbornly sticking to LINQ because there is the way to apply LINQ to give us that number. Look at this. No. This is the board. Playable cells. Every cell leads to a new board. All right? So we have all the boards that can follow from this one. I will even give this expression a name. No. Successors. Those are all the boards that will success this one. And I can even use method group here to make this expression even more compact. So all the successors are the playable cells. Apply make move to them and you will get a successor. This is LINQ in its finest. Look at this. How many continuations do we have? By taking successors dot sum next count continuations recursively. But since some board might not even have a successor because the game is over, I will substitute zeros with 1 so that every ending position is counted as 1 and simply sum them up recursively. What say you? Will this work? Not really. This is where performance penalties have finally hit us. Everything up to this moment worked well. And this one doesn't work. This might take a minute or longer, and I'm not even going to wait for that. Why? The reason is that this algorithm is not good. It is very nice. It could be written as one line of code. Just put this in here, and you will have a single line of code which is doing all that. The problem is that continuations, the recursive calls are made on boards. And the problem is that we are visiting the same board position many times, sometimes dozens or probably 100 times again and again, because there are many ways to reach the same board position. So, in fact, we should remember counts for board positions we saw and pick them from the cache before before counting them from scratch. So I think that I will have a private counter which will receive a cache. The dictionary, for example, which maps board to the count. And it's not gonna be so easy like this. The point is that if cache try get value on this board, then we would return that value. Otherwise, I want to count these, put them into the cache, before returning the value. And I will create a new dictionary for that, hoping, oh, this recursive call must use cache, okay. Hoping that this will improve performance. Unfortunately, it will not, because board would be used as the key, and board is not a value object, nor will it ever be. I cannot override equals and get hash code here to test whether two board positions are equal, because that might not be what somebody expects. Somebody might expect two boards to be equal if they resulted from the same sequence of moves, not only if they ended up being the same when you look positions played. When you have a problem, when you encounter a case like that, you cannot turn that class into a value object. You cannot, because if there are two ways to define equality, then this class cannot choose between them. In that case, you have to implement iQuality comparer. So this will be funny. Board content equality comparer. There must be a separate class which says what kind of equality it is implementing, and it must implement equals and get hash code. So here in the cache, here, we will have to supply a new equality comparer so that the dictionary knows how to compare. And now we're in trouble. We are in trouble. How do we solve this? This could be easy. We might take x dot home cells order by. Order by will not work unless cell is implementing iComparable. And then make sure that it is equal to this. Sequence equal to y, home cells order by. Do you see what I'm doing? And do the same for away cells. I'm comparing whether those sequences of home and away moves are equal. I might then generate hash code in that same way by combining home and away cells, sorted cells. Maybe there is a way to do that. Okay. Enumerable of cell, enumerable cell home cells for board. So I want to extract that board home cells order by cell, and I want to do the same for away cells. So right now I will have sequences of home and away cells. And this away cells of X sequence equals this away cells of Y. It seems like I have implemented equals. Maybe. I'm not sure. And I will take all the cells by concatenating these two, but sorted. I must sort all the home cells first, then concatenate sorted away cells. So these are the properties that the board doesn't have. Sorted moves, and all home first, then all away following. These are the properties that the board doesn't have, and after we have sorted moves, we can even check whether two boards are equal, because any order of moves would be turned to the same form. By the way, I am not in, okay, a compiler would complain anyway. I thought that I could forget to implement compare to. That is compare to cell other. So I don't know if other can be null. Then I will say that this is greater than it. Otherwise, this row compared to other row equals 0. Then use the second comparison criterion, that is to compare columns. Otherwise, use that result. Not the most optimal in speed, but the most optimal in typing speed, in vertical space. All right, so how do we get hash code? By taking all moves and then I will turn all cells into their hash codes and then aggregate using hash code combine. It's over. Another LINQ expression, which is combining hash codes of separate moves after they were sorted. I believe this has good chances to work. I never tried this. By the way, since this could be very slow. I think I will write how many items there are in cache, but not every time. Every 100. For debugging purposes. All right. Are you ready? Sean has Googled some data about tic-tac-toe, so you can check the comment. Let's see what we have here. Oh, this is so frozen. I cannot even open the console. Let's open it first. Okay. So let's see. Oh, look. It is progressing. Exploded. Contains no element. What? It's possible. Yes, yes. I think this is the problem. This was too easy to be true. This was too easy to be true. So let's use 0 to seed it. I believe that was the problem. Code board object select cell. Maybe the initial board was the last one to populate. Maybe. Oh, I forgot this again. Let's restart. There are about 5,500 distinct board positions, legal, those that can be reached through a legal game. While it's working, let me read the Susake. Yes, it works. Why this? Oh, something is not right. Sunny Patel, instead of try get value, why don't I use contains value? This doesn't work. I think here, yes. Because try get value is testing whether the value is there and reading it. And you can do that in one walk through the index, so that the dictionary doesn't look for the same key twice, which is an expensive operation. That is the reason. You should use try get value every time you can, because it is fast. It is twice as fast than doing that in 2 steps. Now the problem is that I seem to be missing something. Did anyone notice the bug? I started to say that there are about 5,500, I think, that I found that many on the internet legal positions. So the cache was apparently populated correctly. I don't know what I'm missing here. Why it's showing incorrect result. Maybe the problem is that this happy coding here was not entirely correct. I'm not sure. But anyway, I might look for the bug later, so not to stop you here. What I wanted to show you is that you can improve performance through caching, for one thing. So to still use expressions from the prototype, which didn't look like it will be much useful later. By the way, this dictionary here could be part of the board object, so that you don't have to pay the same price multiple times. Once you populate the cache, you can use it again. Game counter cache board and int. Okay. No. Board int, that's right. Get. All right. And here, where are my constructors? So that I can initialize it only once and retain it. New dictionary, come on. And new board content, yes. Yes. So we have two components to initialize, and I want to have another private constructor which only accepts moves. And that one no. Forget it. I cannot. I am so distracted by that bug. I cannot focus right now on this. So I will pass the game counter cache to every new instance, so that here there will be no second implementation, but everything will be done on the existing cache, which is shared among all instances of this board. No, yes, there's no argument here, so this will be simpler. That is one thing. And the second thing which I will add is the clear method, which will construct a new board but pass the same cache to that object. Now the cache will survive through all gameplays in the UI, because when I want to restart, I will not create a new board but clear the existing one, and cache will survive. Cache will survive across calls. Did anyone find the bug? Come on, tell me where the bug is. I forgot to start the console, to show the console again. Let me open it. So we will see the progress. And after that, you will see that once we pay this price of evaluating those costly LINQ expressions, so number of board positions seems to be correct. You see, the number will change without calculating again. There's no calculation of anything beyond this. And if I restart, it will show that same result instantly. because there's no reason to calculate all board positions again, because new board has cleared the moves but retained the cache of board positions. That is helping significantly when talking about performance. So there is a problem, which I suspect is somewhere here, but I'm totally unable to figure it out now. What am I missing? I don't know. Cells ordered, away cells ordered, equals should be right. I can't tell what's the problem. So anyway, I will not make you wait for debugging here. I will fix the code and show in the recording where the bug was. And I will end this presentation here. What I wanted to show you, regardless of this annoyance in the end, is that you can use LINQ expressions all the way through to build the entire model and only pay attention to performance when performance penalties hit you, if they ever do. That's the point. In most cases, there will be no penalty at all, no measurable penalty. There will always be penalty if you are using a lot of objects in the process, creating millions of objects, I don't know, and subduing them to sequence processing, to LINQ expressions. There will always be penalty because of using so much memory, so much garbage collection and everything. But you're not developing games, I suppose. You're developing business applications. That is the assumption with which I have started this presentation. Even though this is the game, it doesn't look like something that operates in real time where every nanosecond counts. If that is your case, and I believe that in almost all uses that will be the case, LINQ will be on your side to develop powerful models which are even readable, very easy to use from the consuming end, very quick to develop, and functionally correct, despite this problem where I have eventually developed something that is not functionally correct. I will fix that, trust me. So the point with which I will end, the last comment is the locking need is much lower in multi-threaded environment. Yes. I thought when I saw locking that you will refer to the cache which requires locking. This entire implementation is single-threaded, so I didn't lock the cache. You must make sure that your caches are multi-threaded, thread safe, if executed in multi-threaded environment. Besides that, when you apply caching, you will be able even to avoid penalties when using expensive expressions. In many cases, you will be able to avoid penalty through caching, so that you never have to go deeper into developing more detailed state representation, which would bring you better performance, but that will bring you bugs as well, and a lot of vertical space eaten by large functions. If you can avoid that, stick with the LINQ when it comes to sequences, and you will be better off. That's the point of this presentation. If you have any questions, you can save them for a couple of days before recording appears on YouTube, and you can post questions on the recording. Besides that, thank you for attending, and you may ask for the topics you're interested to listen. I don't know, if you have some good ideas, I might talk about things that you wish to hear. no questions right now, so thank you for attending and see you again in about a month or two.